They're here.
Go ahead.
Hello, Dave.
Hi.
Well, welcome to, let's see, this is the July 28th, 2020 session of Hamside Tangerine SDR discussion. And so we'll work on the list and see what everybody's doing, and then see if we have any special topics tonight. So for me, I've been just working on a few projects, but I kind of got in a funk where coding isn't working well, and a whole bunch of things, and so I keep trying other projects to get myself out of that and back to normal productivity. So that's that for me. Next on the list, we have Nathaniel,
Hi, Dave.
W2NAF. Go ahead.
Hi, Dave. Thanks. Just trying to hang in here. Things are going okay. We're moving along. Working on writing and proposals and data analysis and AGU meeting and all that other stuff. And we got some electrical work done today. So we got
Very good.
a little bit more electrical work done on the house. So they're coming back tomorrow. So that's good. W2NAF back to net.
Okay, and then we have Dan in for XWE. Go ahead, Dan.
Oh, thank you, Dave. Hello, everyone. Well, I got my main computer fixed last week. It was the power supply, which is what I thought it was, and it's a good lesson in fixing computers because it acted just like it was the motherboard, but it in fact was not. And I've had, over the years, I don't know, maybe 10 computers go south on me at one time or another, and I would say out of the 10, 8 of them have been problems with the power supply. So it's probably the cheapest thing to fix, and in my case, it's been the most often thing to fix. So a good lesson. Other than that, worked a little bit more on scripts. I was telling Dave a few minutes ago that I did open up a GitHub account, which is my call sign, /scripts, I think is where all this stuff is eventually going to reside. And I need to write a README file for it, which I think I can do pretty quickly because I've written some descriptions on some of the stuff that I've sent out already, and I'll just kind of pull that back, edit it a little bit, congregate it, and use it as my README file. Anyway, back to you, Dave.
Fine business. And next on the list, we have Dave W. Go ahead.
Oh, hello. Yes. I haven't accomplished much at all lately. Don't have much to report. I think I'm in kind of steady state on most things. There's odds and ends I'd like to clean up, but until I know more about what the status of the magnetometer stuff is, I don't know anything else to do. So I'm mostly spinning my wheels. I've been in a funk too, so I think it may be just in the air. Back to y'all.
Okay. Well, next on the list is Mike, AA8K. Go ahead, Mike.
Greetings to everyone on the conference. Still recovering from my 12-day conversion of Mist TV and Ubuntu 2004. I did enjoy the DX Engineering Hamfest on the weekend. Thanks, Nathaniel. You did a great job. Back to you, Dave.
Fine business. And next on the list is our newest ham, Veronica, KD2UHN. Yay!
Hello, thank you. So yeah, this week was an exciting week for me because I passed my technician license test and now I have a call sign. And then aside from that, I have been working on looking at some graphs that Dr. Purcell and I generated and trying to eliminate some questions we have about what we're seeing. And then also just regenerating them to eliminate what we think could be some questions. So that's all.
Fine business. And next on the list, we have David, AC7DS. David, any comments?
Well, I'm new to the group and still trying to figure out what's going on, but I am trying to build an SDR, and I would love for it to be modular like the Tangerine is going to be. And I'm more trying to learn what's going on than much of anything else and trying to play catch up at the moment.
Well, you're welcome, and come and join us. Once a week we have this discussion, and there are lots of projects that aren't all allocated. So if you find something that is within your capabilities, jump in. Okay, next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay, very good. Hi, Dave and the group. Yeah, this week's kind of been a funk also for me. I got news that that FPGA image that I built about a month ago doesn't work at all. So it's bad enough when it misfires a little bit, but it doesn't work at all. It's lends you to question your ability as a programmer, you know. So, and it's one of those things where I don't have any hardware to test it, so I used to have to throw it over the wall and let them test it. And I can't even test basic functionality without setting up a simulation. So, and I haven't done that yet. So, anyway, I've been working on the Tangerine DE data engine, trying to get that going. Working on the power supply mostly right now. So, I had a question for Tom when he gets around to yours. I'm looking for the power requirements for the RF module. I think we discussed this a long time ago, and they're buried somewhere. So if you have them nearby, that would be great to assist. And I guess that's about it for this week. So back to you, Dave.
Fine business. Next on the list is Inky or Inny. Go ahead.
Good evening, everyone. It's my first time here as well. I was sent the invitation by Bill, AB4EJ. So I'm here to observe and learn. Thank you.
Well, welcome, and please come back if you find it interesting. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't really have anything new to report, but if there is time, I would like to discuss power for the Leaf module. Other than that, that's all I have. Back to the net.
Fine business. Next on the list, we have Dev. Go ahead, Dev.
Hello, everybody. Good evening. So we have been continuing to work towards receiving CHOP ionosonic signals at the University of Scranton, here in Scranton. We have assembled N200, ETAS N200 SDR, and we also have now QA SDR connected to a machine to see the HF signals on the web interface. Now we're, I think, very close at detecting the CHOP ionosonic signals. Once we confirm we are detecting the CHOP signals, then we'll collect the data. And then the next step, we'll discuss the science questions that we can pursue. So we're getting to where we want to be, and I think it's generally true. We don't get to where we want to be at the pace we want to. Thank you.
Well, that's usual that you don't get there as fast as you wish you could. Okay, next on the list, we have Tom McDermott, N5EG. I got that right, Tom, didn't I?
Very good, Dave. Thanks. Welcome to everybody. I'm just bringing up the conference call notes. I've got the power supply requirements summarized in there, but I forgot which week between January and now, so I'm searching through them. Nothing on the project. There were a couple of YouTube videos reviewing the new Odroid N2 Plus, which is a higher clock speed version of the Odroid N2. And that may be of interest to some folks on the list. So back to you.
Yes, and I think also that Odroid has eMMC memory, which speeds up a lot more than the SD card.
Yeah, the reviews, the one review I saw, the IO speed up was about 7-to-1 over the SD card. So it's a substantial performance improvement.
And I don't think it is substantially more expensive than the old one, is it?
I didn't see the pricing. I just was looking at the reviews, and it looked kind of interesting.
Anyway, interesting new pieces. Next, we have Elizabeth. Elizabeth, it's been a couple of weeks. How are you doing?
Hi, I'm doing good. I don't have much to update you guys right now since I've been playing catch up as well. Got my COVID test, my second COVID test back today, and it's negative finally, so that's good. And then my only update is I'm going to be submitting an abstract for the HAMSci AGU section. So I'm working on it right now. We'll be submitting that probably by tomorrow.
Hey, thank you.
I saw the
Nathaniel's
email.
happy.
Yeah.
Yeah, we need more submissions.
I'll be submitting mine by tomorrow.
Thank you.
And that's
Okay.
it.
Next on the list is Dave McGaugh, N1HAC. Go ahead, Dave.
Hi there. I actually have some results to report. I have been able to get the magnetometer up and running, and I've compared it to the magnetic field values that we have here, and they match. There might be a sign error, but in terms of actual magnitudes, it seems to be reading in micro Tesla. And so that's very encouraging. The one thing I will mention is it's not reading the temperature sensor. It's giving me an error. I presume the address on the temperature sensor may not be set properly.
That's easily fixed.
Yeah, if you could just give me a clue what it's asking for something at hex 19, and apparently it's not there.
You have to move a jumper, perhaps, or remove a jumper, and it'll go to 18. Or else you can, I believe the software lets you set, depending on which software you're using, it lets you set an address for.
Okay, I figured it was something very simple, but I didn't have time to check that. I was focusing on getting numbers out of the magnetometer, but hey, it seems to be
Good
working.
job.
Good job, yeah.
Let's finish the list and then we'll go to general discussion, unless you have more.
Nope, that's pretty much the most of it for me.
So next on the list is Bill Engelke, AB4EJ. Go ahead, Bill.
I think there's a note in the chat from him that says his audio is dead.
His audio's dead. Okay. Well, then he's been acknowledged. He's here. And next on the list, we have David Lewis. Go ahead, David.
Good evening. Is my audio up?
Just fine.
Yeah, okay. Yes, I'm a ham, W2HMT, Hotel Mike Tango, and have been reading the mail, as we used to say in ham lingo, since the founding of HamSci. Nathaniel, you may have heard from me a few times in the past regarding my interests in eclipses, and upper atmosphere ionization and things of that sort. Had a number of contacts with atmospheric chemistry and physics over the years, and just like to keep in touch. So all the ham-sci stuff goes into a separate file on my email, and when I get a chance to get to it, I read it and catch up, and saw the announcement of these evening sessions. So you may see me click in from time to time. I have a few minor projects going on now, putting together a Whisper apparatus, and hope to be able to get into digital modes, and especially propagation enhancement. A lot of my career in chemistry has been in spectroscopy, pulling very weak spectroscopic signals out of a lot of noise. So this is a familiar area to me. Anyway, I'll keep it short. So good evening to everyone there. Glad to.
Very good. And welcome. So that's the end of the list. So we're open for general discussion.
Scotty, I found the power supply requirements from the December 30th, 2019 call notes. You basically plus 12 volts at 10 milliamps, typical, plus 5 volts at 160 milliamps minimum, 330 milliamps maximum. That's basically the, between none and all 6 relays pulled in. Plus 3.3 volts at 100 milliamps, and plus 1.8 volts at 65 milliamps.
Okay, thanks.
And I'll copy that in the call notes, so they'll come out on the mail list after the call.
Okay, good, thanks, that helps. Also, one thing I'd like to announce to the group, since this seems to be the group of movers and shakers and people doing research or building things or whatever, DCC is coming up in September, and we're looking for articles or presenters. So whatever you've been doing, Tangerine or otherwise, feel free to well, put together a presentation, I guess. The idea is we're going to use Zoom to record them, and they're going to be pre-recorded with sessions afterwards for Q&A. So there'll be 2 lengths of sessions, 15 minutes and a half hour. So 15 minutes will be more like 10 minutes with a 5-minute Q&A, and the 30-minute will be a 20-minute with a 10-minute Q&A. So if you have any interest in doing that, I'm not sure. Dave, do you remember where is it up on the website yet, the submission address? You're muted. You're muted, Dave.
Yes, I believe it is. It's on the Tapper website. We've been working on getting the place to sign up. If you want, the best thing to do is it Maddie or is it Steve collecting the submissions?
Matt is collecting the ones for publication, and Steve's collecting the ones for presentation. You could write a paper and have it put in the proceedings, and you don't have to present anything. Or you can present a paper and not put anything in the proceedings if you like, or you can do both. It's up to individuals.
And the proceedings are published with ISBN.
Right.
All right, Dave, I'm back in. My computer audio card apparently died, so I'm in by phone and by video on my computer is working for that much anyway.
Yeah, Bill, go ahead and give us whatever report you wanted to give.
Yeah, been real busy here. My wife is in the hospital at UAB getting treatment for her monster lung infection, and so I'm having to go back and forth on a daily basis, 75 miles each way. But anyway, she's getting better, so that's a good thing. But as far as a project, I finally have it working where I can run not a simulation anymore, but actual copying data, where I can run 6 channels, 8 kilohertz it's 48, a single channel of 48 kilosamples per second, and at the same time copy 2 channels of FT8. Now, I think the system will do more than that, but this is what I'm able to get out of the Flex interface right now. I think I've had it running 3 FT8 channels. You got 4 slices on the Flex 6600, so I know I could do that. It was tricky to get that working because there's a lot of interference between the different threads. So I finally wound up breaking off the FT8 to a whole separate process, which I spawn that off from the main control and then kill it when I'm done with it. And that is working. So, and I started before I went to Birmingham, and it ran from noon until 5:30 p.m. So that's a pretty good test for it. It was collecting data, storing it on the hard drive in digital RF format, and collecting FT8. Next thing I need to do is I need to write the code to upload FT8 spots to PSK Reporter, but that's not a high priority. I have been working a little bit on the use case for the data engine. That'd be of most interest to Scotty. The use cases, I recognized that I need to be able to create at least 2 configurations and give each of them a number so you can start and stop them by number. The reason for that is we need to collect samples for digital RF, for example, for our spectrum analysis, and that's at 8 kilosamples per second, and a separate set of channels for FT8. So I'll probably have 2 channel configurations, one for standard spectrum data collection and one that's going to the ring buffer, and one for FT8. Might have another one down the road for Whisper, but I haven't addressed the Whisper stuff yet. That's a little bit lower priority, but the next thing I'm also going to do is work on getting the fire hose mode to work. That's why I asked Inyene or Inni to join. She is the graduate student from UA working on the project, and we're working with getting some advice from her on what exact technique we're going to use for uploading that to the server. So anyway, that's my report. Back to Ned.
Bill, I have a quick question for you. You pulled out from a Flex data stream. I was wondering how hard it'd be to take the HPSDR data stream and do the same thing.
Well, I did have that. I had that working. That's how I started. I was doing that using the Red Pitaya, running in HPSDR emulation, a version 1 emulation mode. So I have done that.
Okay, good. Thank you. And can I ask you one quick question, Bill?
Yeah.
Are you using the 14 or the 16 Red Pitaya? 14-bit or 16-bit?
It's the older model, so I believe
14.
Probably the 14-bit.
Yep.
Yeah. So it doesn't have the resolution to be able to watch WWV.
Okay.
So you can look at it and see a little bit of something here and there, but it's not the kind of the level of science analysis that we're looking for. But it allows you to test like a proof of concept thing. I use it basically as a proof of concept.
Very good.
Yeah, so Bill, when you say you got 2 streams going, then you really have separate streams with separate formatting going at the same time, like our protocol calls out, right?
Yes. Yeah.
That's pretty impressive.
The formatting is, the way I'm doing it now, we're using the same formatting between the 2 channels, but they don't have to be. you know, what I had in mind for the Tangerine was to use what I call Vita T, which is a packet format that is conformant with Vita, except if you turn on multiple subchannels, it will interleave the data. Like we had this very conversation at Dayton, a year and a half, 2 years ago, whenever it was, interleaving the IQ data from the different channels in a single buffer. The way that Vita is, the off-the-shelf Vita standard pretty much looks for you to have a separate stream for each subchannel. And that is a royal pain, because if you have multiple subchannels running, you can't really synchronize them very well, especially in a non-deterministic network running UDP. It would really be a nightmare to try and tie all that back together. So I came up with what I call Vita T. It will have a different bit set in the header, which will tell any software that wants Vita data that this is not a legal Vita format or legal Vita packet. However, it is also my proposal is it'd be also possible to run the Tangerine in Vita compliant, full Vita compliant, where you have a separate stream for each different subchannel, and that's how I handle FT8. So I'm doing them both right now.
Yeah, and that's the whole point of our protocol, is that each of those formats can be defined, and they can coexist on the wire. And when you set the stream up, you set it up the way you want, whether you want an interleave or you want each channel separate on multiple streams, or how do you want it?
Yeah, and so the nice thing about this is that if there is software that's out there, and I think there probably is, that looks for full Vita compliance, the Tangerine should be able to run that out of the box. When we go for the very, very high performance data collection that we're looking to be compatible with digital RF, it'll go in this, we can set up that channel group to run Vita T, which is kind of, it's like, it conforms to Vita except for the fact you have interleave channel data.
Yeah. And I think that we'll be able to make an FPGA image that will do a subset of these different formats as required. Right? Because it's just going to be the data engine is going to have to recognize what kind of stream format you're asking for and be able to comply.
Yeah, and that's part of what I'm going to add that to the channel request. It's just a bit. Do you want Vita compliance or Vita T compliance? Right. I mean, we can certainly make it so you could have several different formats, but this is phase one. So
you do that when you set the stream up, because you set the format up you want. Yeah.
Right. Yeah, and I modified my simulator so it reads data off the Flex system and generates the multiple streams for FT8 and a single stream for standard spectrum data collection.
So now you have 4 or 5 different formats, right?
Well,
stream formats, I mean.
I threw away. I've got a lot of code that I'm just marking as obsolete, because for phase one, I think it makes the most sense to support just 2 formats: full Vita and Vita T. You get too much rolling in there, and it starts really becoming a mess to keep up with in the code, and very bug prone.
I do like the idea of having the formats defined, however, so that if you want to do something specialized, you can do that, and you'll have a defined format that gets generated.
Well, it sounds like you're talking about are you looking for the SBC to send some kind of XML thing to the data engine that says, here's the format I want? I wouldn't recommend that for phase one.
No, not for phase one, but I want to make sure it's extensible so that we could do something like that in the future if we want. And it's just a matter of defining the types of formats. And I think we're going to find out really quickly which formats are usable and which ones we don't really care about. And so we can throw those away. But there'll be ones that'll be useful, and there may be ones that other people are going to find useful in the future that we haven't thought of that are going to be required. And I can't really come up with any definitive example of that. But since this is a work in progress and it morphs as we go along, you never know what formats might be required. So if we keep it open-ended so we can define them any way we like, then we just define the useful ones, and then if we need a new one, we can define a new type if we need it. That's kind of where I was coming from at the beginning.
Now, Scotty, when do you think that you're going to be ready to start programming the data engine in earnest, where you're going to be waiting on the format specification? Because I can make that a higher priority than anything else to make sure that you have it and you don't have to wait on it.
Well, I think I'm going to get started on the FPGA code next month, but Dave and I have a lot of programming work to do ahead of time before we start getting into protocols. So I'm thinking September, after DCC probably is when we're going to dig into it.
Well, I was thinking, I got to work on this by next week. It sounds like Scotty's just about ready to start. Yeah.
I wish I was that far along, but too many things have gotten in the way. So now it's going, but I'm a little bit behind here, so I'm trying to do catch up.
Bill, can you give me a pointer to or a better name for Vita T? I did a quick look on Google and couldn't find that.
Vita T is something being designed by me. Vita 49 is probably what you want to look up. If you want to look up something, VITA-49, that would be the standard SDR data stream protocol, which a number of devices support.
Okay, so what is this T designator? Is that described in the standard, or is T your proprietary thing?
The T stands for Tangerine. It's the same as Vita, except it uses the IQ interleaving that we're going to do with the Tangerine.
Okay, very good. Thank you.
So, Bill, does Vita 49 specifically prohibit interleaving?
Well,
I didn't think that it did.
I looked at at what it takes to do the interleaving, and it is over the top complex. And the problem is, I'm trying to get something you can do in a microcomputer at speed that is easily interoperable with digital RF. You would have to get a buffer to use Vita 49 and use channel interleaving. You would have to get a buffer in Vita 49 and reformat it quite substantially to be able to feed it into digital RF.
Okay, well, that's a problem.
I'm trying.
That's a problem.
I'm trying to avoid that.
But
yeah, I mean it.
In terms of the Vita 49 spec, is there anything in your Vita T that really violates the Vita 49 spec to say, oh, this can't be Vita 49 because of some format that you put in?
I'm sorry, I don't know how to answer the question.
Well, you have two versions. You have Vita 49, which is the more general spec, right, which is the published one. And then you're saying that you're taking some liberties with it and making some mods to it and calling that Vita 49T. So what are the mods that you're making in Vita 49T that would make it not Vita 49 anymore?
A single modification in that you use interleaving of the subchannels in the buffer.
Okay, but I thought that Vita 49 didn't specify what the data packet was like, so it could be interleaved or not. So inherently, it doesn't violate Vita 49. So your Vita 49T would still be Vita 49 compliant, even though the data frame would look different.
Well, when I looked at Vita, the full Vita specification, and looked at what you have to do to support multiple subchannels, it's a mess. You've got you've got some stuff in between each IQ sample to identify what it is. At least that's the way I interpreted the spec. So it's not just as simple as IQ for channel 1, IQ for channel 2, IQ for channel 1, IQ for channel. It's not as simple as that. There's some stuff in, there's overhead of some additional identifier stuff that you have to put in between each IQ sample in order to identify what subchannel the IQ sample is for. And so now you've got these little bits of stuff in there that don't fall on nice 8-byte boundaries and stuff. I mean, it turns into quite a programming. Put it this way: if we had unlimited time, I guess we could do it. But we need to start. We need to start out simple.
So what you're saying is then that the data portion of the VITA 49 packet is not data anymore. It's data plus some of these header extra things that you have to stick in. So that makes it not VITA 49 because it's not just strictly data.
Well, no, I mean, I'm telling you that the VITA 49 specification states that you can do this channel interleaving, but the way they do it is put stuff in between each IQ sample to identify what that IQ sample is for.
So they actually specify this multiplexed format then? In VITA
Yes.
49. Okay, I was under the impression it was all free form and you could do it any way you wanted. But that's not true. That particular interleaving specified. So that makes it
the way I interpret it.
That makes it unlike HPSDR, which is simply IQ1, IQ2, IQ1, IQ2, IQ1, IQ2, and there's no headers in between.
Yeah, and that's what I want to use for this, and that's why I said VITA 49 is kind of like a amalgam of them.
So it's more similar to the HPSDR protocol 2 then, for the multiplex string.
As far as the data portion, the spectrum portion, there's a header in the payload. The first part of it is a very nice header, which is very cool. I mean, it's got some good stuff in it. I'm using an adaptation of that where instead of, I use a buffer count rather than a sample count, because otherwise then you have to count the samples inside the payload. Anyway, but obviously when I'm writing the specification, it will include all of that. So it will be, try to make it as clear as possible for when you get ready to do the FPGA code, develop it, to generate it.
Okay. So then we could include the VITA T format if we wanted to garbage it up like that, but then it's not going to be very useful to us because you're going to have to unpack all that and it's not going to be a mess like you said.
Well, here's the thing. If all you want to do is you want to run each stream as a separate, each subchannel as a separate stream, the VITA 49 as it is works fine. In fact, that's exactly how I'm doing FT8.
Right, but I think
FT8 uses full VITA 49 compliance.
Yeah, but your multiplex streams doing it VITA 49T with your non-headers with just interleaving, that's really, I think that's a good format also for us.
That is right. That is for the spectrum stuff. The FT8 uses full VITA 49 compliance. The spectrum stuff uses this VITA 49T, this our homebrew version of it, because that interoperates well with digital RF.
Right. Okay.
You can use a buffer just like it is. You take the buffer and you just plop it in there and boom, you write it out.
Yeah.
And then you can run that at high speeds. If you have logic that has to start separating stuff out, and basically you're going to have to split buffers across multiple packets, and oh my gosh, what a mess it turns into. I'd like to avoid that, at least for phase 1.
Yeah. Okay. Thanks for the explanation. I was confused.
Yeah.
Scotty, I'd like to inject that when we were working on Protocol 2, we looked at VITA 49, and this was one of the objections to. We basically made something that took some of the flavor, but didn't really
we
make the 100% jump.
We kind of did VITA 49T. That's
kind
of what we did. And I presume that when you turn VITA 49 compatibility on in Protocol 2,
Yeah.
You don't get the funky format. You get our interleave, or simple interleave format, right?
Yes, I think so.
See, I missed that totally when I read the spec, the VITA 49 spec. I didn't realize that there was something defined for interleave format. I thought the interleave format was like what we did in HPSDR, but apparently that's not true. So.
Well, and it makes sense if you're just collecting data and you don't need to coordinate it for post data analysis. And one of the big pushes here is we'd like to know on each of the bands that we save, if a signal comes in from the atmosphere or space, we'd like to know which actual elements are aligned together.
Yeah,
That's what Bill's working on.
You're trying to correlate multiple streams.
Right. And most people that are just point-to-point communications are not trying to do that.
Right.
They're not trying to do interferometry or any of those kind of things. Yeah.
HPSDR was really kind of, I know there were some guys that put 4 Mercury boards in one system.
Yes.
The clocking of that to get it synchronous was problematic since the clock was point-to-point. And they sort of got it to work by cheating and making it multiple drop. And even though it wasn't supposed to be, I guess it worked, but I heard that they had problems keeping the FPGAs aligned, the clocking of the FPGAs aligned.
Yes. Well,
I mean, just think about if you're doing something as simple as looking at the ordinary and extraordinary aspects of a single signal. Those signals have to be locked together. If you want to look at the phase angle between that, I mean, those have to be locked together. You can't have them split across packets and all that mess. It doesn't work.
Even if there's a phase difference, they need to be locked together in frequency. Otherwise, it won't work.
And even Ben on Nathaniel's talk on Thursday, Ben was talking exactly about this, how he was able to take a HPSDR and make it do what he needed for phasing.
Well, it's going to be interesting to see how we can phase lock together multiple data engines, whether that's really going to be possible. The theory is we will be able to, but the theory and actually doing it, a little harder.
Be easier to put more sockets on than to
Well, you can
have more engines.
Just using 2 RF boards, you can get 4 synchronous channels.
Yeah.
But if you want more than 4, I mean, we're talking like 16 synchronous channels. So 4 data engines with 2 boards each. And
yeah, if you could get them synchronized, that would be amazing.
Yeah.
We may have to think about GPUs, Scotty.
I get enough to think about already. Just getting the first one.
That's another whole level of programming there, too.
Yes, I know, but
that's only software, Bill. That's easy because I don't have to do it.
Right. Everything is easy as long as somebody else has to do it.
That's right.
Well, it always looks easy when it's done.
It does, right? Especially if
I agree with that.
Yeah, I've got several software modules that are pretty small. That's because I took out the 9/10 of it of stuff that I tried that didn't work. You have to. I mean, I didn't realize there could be so much contention on one of these Linux devices between the threads in a single program. They fight each other in some cases, and so it works much. I find out I have to spawn it off as a whole separate process, and then of course now you got the inter-process communication. But it's getting there though.
So Dan, we're gonna have to buy new Odroids if they got the N2 Plus.
Well, I don't know how important that really is because I've got this thing running 48 kilosamples and 2 FT8 channels, and it's only using 15% of the CPU of one of the CPUs, and the other CPUs aren't doing much. So I don't think we're really pushing it.
if there's a faster one, you got to have it. I mean, that's just.
Well, no, I mean, the Case Western people are pushing me to get the whole thing running on a Raspberry Pi, so I'm looking at going to slower machines rather than faster. So
I don't know. I think that's the wrong way for geeks. You know, you got to have the best and greatest.
Well, I mean, it never hurts to go faster. I mean, that's you know.
Well, I know I bought about a dozen single board computers to do testing, and one of the ones was a Udo x86. I don't know if you ever heard of that, but it's like a quad core Celeron. I think it's a quad core, but it's like almost $300. So it's really out of the league of single board computers. It costs as much as a motherboard does. And by the way, that $300 doesn't include the memory or the disk or the traditional stuff. So yes, it's small and it's low power, but wow, it's expensive. But it performs.
Yeah,
it one,
sounds like something they developed for the military.
At the beginning, Jonathan Rizzo asked a question about the power supply requirements for the VLF receiver on the DE. Jonathan, do you still have that question fresh in your memory?
Yeah, I just wanted to clarify again that the way the leaf board was designed, power would be coming from the Raspberry Pi header connector and not the M.2 connector, correct?
Actually, it'll be coming from both. There's each connector has 1.8, 3.3, and 5 volts. So you can pick what you need that's closest to what you need to generate the voltages you need.
Where do you put
Okay.
Dave W., did you have a question?
Where do you put the 1.8 on the Pi connector?
Right. There's a pin for that on the Pi connector.
Is there?
Yeah, I'm pretty sure of that. Let's see. I haven't hooked up to a pin. That may not be a good idea, but
I don't know. It's just might confuse something. I don't ever remember seeing one for that. And these processors run at different voltages.
Yeah, so let's see what for the RPI connector. I have 1.8 connected to pin 38.
38, okay.
And it says VDDIO_A01V8. Now, I don't know if I think that's an analog output on some Raspberry Pi versions.
Uh-huh.
So
But that's from the Raspberry Pi spec, the official one or something?
Well, it's from one of the multitudes of connector pinouts that I got off the web. So it's
okay.
It needs to be checked to make
Yeah.
sure that I'm not going to burn anything up by putting 1.8 volts on. Like if that's an analog out, then that's not a good choice.
Well, it could also be a reference voltage for the analog, I would think. But it's not it's not a commonly used thing. But those pins way out there at the end, is the 38s at the far end.
Right.
So I don't know a lot of things that those are used for that I've run across.
At least you can expect on the slow speed connector 3.3 and 5.
Sure.
And if 1.8 doesn't work out on that connector by the time I'm done with the research and figuring it out, it will be present on the leaf connector. So, but I'm expecting if you're going to use 1.8, especially if you're going to use analog 1.8, you're probably going to want to generate that yourself, Jonathan, from the 3.3 or the 5, whichever. Because you're going to want to generate a nice clean version of it for your onboard use.
Yeah. Just like you and Tom said, for the analog, I'm going to use an LDO, but I just wanted to verify that there were those voltages available on the M.2 connector for use.
Yeah, 'cause I know Tom used the 1.8 volts directly, but Tom, you used that just for digital stuff, right? So any
Yeah.
analog stuff, you had your own regulator.
Yeah, I treat all the digital supplies, I treat all the voltage supplies coming in as digital supplies. If I need an analog supply, I make it myself on the board.
Okay.
Good rule of thumb.
Well, with this board, I was thinking of omitting the Raspberry Pi header connector because that won't really be needed with my board. Is that okay, or did you still want?
No, because you mechanically have to have that header in order to hold down the board, hold down the board in the M2 connector on the other end. So even if you connect nothing to it, you still have to have the physical connector there.
Okay.
I mean, technically, I guess you could put a screw hole and a threaded standoff, but that's not really, if you put a connector there, it'll plug right on the board and there won't be any problems. If you put a header there, I mean a standoff, because actually I wasn't planning to put a standoff on the data engine to hold that board down, because that connector first of all, it has holes on either side of it, the 40-pin one for the Raspberry Pi. And second of all, that connector is very tight. I mean, there's 40 pins. So when you push that thing down, it doesn't go anywhere. So you really don't even need a header. You don't even need a screw or a hold down or anything. But if you don't have any connector there at all, then you're not going to get proper alignment. So you're going to have some other way to do the alignment then.
Oh, okay. All right. Well, then, in that case, what I'll do is I'll just leave that footprint there, and I'll leave the connector there. Okay.
And are you going to need any low-speed I/O like I2C buses or anything like that? Because you can get those off of that connector.
Tom said that his RF boards are using SPI, correct?
Right. You can get SPI or I2C off of the header.
Yeah, right now the RF board is using I2C to talk to a couple of interfaces on the board, and it's using this weird 3-pin SPI to talk to the A to D converter chip.
Oh, okay. Well, I have the choice of I2C or SPI, either or. If I want to use it on this IC, so I'll probably just stick with I2C. This way, it's only 2 wires, and it only needs to set the registers and configure it. Doesn't really need anything else, so I'll probably stick with I2C in that case.
Okay, so you can get that off of the header connector, and I believe the way we set it up was the header on the data engine is going to be male pins, just like the Raspberry Pi. And then because the board has to be mounted so close to the Raspberry Pi, to the data engine rather, because the offset, the vertical offset of the M.2 connector is only like 4 millimeters. So you can't put a connector on the bottom of the board. So what you have to use is a bottom entry female connector and mount it on the top of the board. And then you have clearance holes in the board that the pins go through and up into the connector that's mounted on the top of the board.
Okay.
So does that make sense for?
Yeah. Is it in your, well,
Well, what we need is a leaf ICD, which we do not have yet. So an interface control document that says where all the connectors are and how to lay out a leaf board.
Yeah.
And the pinouts of the connectors.
Well, once you have a physical mock-up available, then I'll take a look just to double check and understand. So the Raspberry Pi header connector would be on the bottom of the sleeve board, and that'll plug into the
no, it'd be on the top. No components will be on the bottom, because the bottom of the leaf board goes next to the data engine.
Oh, well then, when you mentioned alignment, I thought that's how alignment was being done. Oh, all right.
I'll tell you what, I got a picture here of a mock-up that I did. If I can share my screen here and show it to you. Just 1 second, I gotta find it here.
All right.
It would be on.
Well, we're waiting for Scotty to rummage through his files. Veronica, I have a question for you about the exam.
Sure.
What were the mechanics of taking the exam? I mean, did you have to download the questions and then provide an upload of the answers?
So I took it over Zoom through MIT. So about like 20 minutes before the test started, they sent me an email with a Zoom link. And then from there, they gave me a website to go to. I think it was the Ham Study website, if I'm not mistaken. And then I shared my screen with them, and they watched me take it through the computer.
Oh, okay, great. I was just kind of curious how that was handled, because I read the literature on the MIT website about taking the exam. I have a son-in-law who is going to take the exam, not,
That's
sometime, I'm assuming. He says he is anyway. So I think that would be a good opportunity for him to do it.
Yeah, it's not that bad. And I think the next one, if I'm not wrong, is August 19th. So
Yes, that's right, I think. I think there's one maybe there was one like Saturday, this past Saturday or something.
I'm
Anyway,
not
you're
sure.
right. They're having them like every 15 to 30 days, they have an exam. Okay, great. Thank you.
No problem.
Well, I'm having difficulty finding a picture here. Probably the best way, if you go on the Tangerine SDR website, and if you look down at the bottom, there's some videos that Dave has put up there that show me showing off the mechanical mock-up to Jason from Ham Radio 2.0, and I show how they fit together, and that may be the easiest picture for you to come up with. I'm not having luck here. I found some presentations that have drawings, but none of them actually have the pictures of the boards that I built.
Okay.
So
right,
Scotty, also the presentations you gave at both Dayton and DCC on Tangerine are up on that website too.
Okay, and those don't have pictures here, but last week I put this up out of a presentation, and now I can't find the presentation. So it's like, great, I lost it. Speaking of the website, Tom did add a folder to the documents page for the white papers, and he posted the white paper there. Thank you, Tom.
Before we're done, I have something about the magnetometer I could share. But whenever there's a
Go ahead,
moment.
Dave, while I'm looking for this, because I'm not having any luck finding it.
Okay, I thought I'd mention that while I haven't accomplished much lately, I have a note from Julius Maddie saying that he will distribute results tomorrow, but he said he thought I'd like to know that driving the RM3100 magnetometer with a known field using a Helmholtz pair and a wave shape at 3 different levels from plus or minus 50 nanotesla to plus or minus 2890 nanotesla, sine wave period of 30 minutes, gave results within 5%. Since runs took at least an hour each, I only tested one axis, but based on other work, have no doubt that the other 2 axes will provide the same results. So he's going to have some specific measurement perhaps tomorrow. I don't know too much about his Helmholtz setup. Apparently he had worked with one in the past and has resurrected it or something. But he usually knows what he's doing when he's testing things. And I just thought I'd let that be known.
No, that sounds good. We'll look forward to it.
That all sounds very encouraging.
You look like you're about to fall asleep.
Yeah, I think I need to check out. I'm just totally beat today. But I did enjoy the telecon, and I'll leave. I made, I think, you, Dave, a co-host and Scotty a co-host.
Okay.
So you guys should have the power to control whatever you need to control. So
Okay.
all right. Thank you so much. It all
Yes.
sounds really good.
Go take a rest.
Thank you. And
I'm
if
going to take a well-deserved rest.
all right. Thanks so much, everyone. Take care.
Okay, I finally found it. Amazingly enough. If I can get... Okay, so... share screen. Let's see if this actually works. Okay, can everyone see that?
Yes.
Okay, so up here is the Raspberry Pi pseudo header, the one that looks like it's a 40-pin one that is placed in the same spot as the Raspberry Pi. The M2 connector's down here. So you could theoretically, you could eliminate that one and you could use these 2 screws as the hold downs. These 2 screws here are hold down. These are solder in ferrules for the RF boards that go on the back because they have to have screws that hold them in. I have a little bit better view here. Let's see. This is the leaf board. And of course, it's all solid copper, but this is the top view. So you see the connectors on the top, and it's got holes on the bottom where the pins go through the board and into the connector.
Oh, okay.
I don't think I have a bottom view of this board, but this is a bottom entry connector is what they call it. It's the connector is designed to have the pins come up through the bottom and mate that way, not through the top.
Oh, I see. Okay.
Okay.
And this is the only way I could make it so that the leaf board could meet the specification of the M.2 connector without being at an angle with relation to the data engine. Because there's only 4 millimeters between the 2 boards when this connector is mated. So this has to come right down onto some 4 millimeter spacers that are on the data engine.
Yeah, I was kind of wondering how that would work, but I understand now.
So you don't want to put any components on the back of the leaf board, all on the top. Although you could theoretically put bypass caps or some very low profile components, but you're going to be fighting with the data engine putting its low profile components there, so preferably not. And because 4 millimeters isn't very high, very much space. So,
is there anything hot going to be underneath it on the data engine?
No, but there may be some noisy things. So that's another argument to stay away from. Keep the backside as much copper as you can. The heat is going to be out from under it, if we go back to the previous one here, this is the FPGA. So the leaf board goes in right here. I got it sideways, right?
Right.
And this is the FPGA, which will have a heatsink on it. And the remainder of the components are going to go along in here. After my CAD guy explains to me that I'm insane and there's no way they'll all fit.
We have a phrase for that: 10 pounds in a 5-pound bag.
That's right. And that's why he's paid the big bucks to make it work.
Yep. I've been tasked with that before.
Yeah.
Well, he's worked with you before, right, Scotty?
Yeah. So he's used to my ridiculous demands.
Yes.
Although you've seen the HF2 board that's in your IQ2, right?
Right.
Have you seen the HF1?
Yes, I have one, I think.
Well, the original size for the HF2 was going to be the HF1 size.
Oh, I
And
can
he
see
told
why.
me, yeah, and he said, there's no way in hell that's going to ever happen. So you might as well just start making it bigger right now.
Yeah.
A lot of people tell me that it's impossible. So I guess, things are impossible. Like the HF1, I wanted to make it 2 layers. And the linear tech guy told me that, well, I don't want to say in polite company how he described it, but he said in no uncertain terms it wouldn't work. And for him, see, there's no works badly or is noisy. It's like it either works or it doesn't work. In his case, he was saying this is not going to effing work. And he really got on my case about how you can't do this. It will not work. But then he also told me that the HF2 would not stay cool enough either, and it works okay.
Yeah.
With the airflow that we have, we made that work. So he's not always right, but he's right often enough that you need to listen to him, because when he says something, there's a reason why.
Yeah.
He's one of those guys you hate because he's obnoxious, but you don't mind listening to him because he's right most of the time.
Yeah. Well, you do want it to work.
You do want it to work, and he was right on the single layer. I mean the two layer, and I think it's a 4-layer. HF1 is a 4-layer board.
Yep.
But he points out that you and I said, well, I'm designing a 1 megahertz receiver, broadcast band receiver. Why do I have to? I mean, 2 layers should be plenty. He says, no, you aren't. You're designing a 1 gigahertz receiver that's listening to 1 megahertz.
Yeah.
Because the front end of the ADC responds up to like 700 megahertz or 900 megahertz. And if any of that energy gets past the filters, then you hear it. Pulls right back in just like it was there in the baseband. So
Right.
yeah, okay, he's right. I hate to admit it, but take his advice though, you get a better product.
Yep, that's right.
Did you actually kind of fabricate that double RJ45 jack by soldering two of them
Oh,
together?
you found me out. Yes.
That's interesting.
That one is a fake double height. You can buy one that is real double height, but I didn't have any in time for DCC, so I cobbled that one together.
Well, I even looked at it up close, and I hadn't noticed that, but I see it
And you can
now
see
as
the
I'm
pins
staring
here
at
for the
this.
upper one, right here.
Yeah, I noticed those, and the solders on the side.
Called out again. Darn.
Gotcha.
Yeah. But they do really make one like that too, and they actually make a USB connector. They make a vertical one that's rotated 90 degrees, so it's vertical. I'd never seen that before either, but
Oh yeah, just about every orientation you could imagine.
and I pretty much made the executive decision to lose the PMOD and the Grove connectors on the board, because I think if you want PMOD and Grove connectors, you put a leaf board on, because I don't have the room and I don't have the I/O. So
Oh, you were gonna put them on the base TE?
I was going to put them on the base, and I think this has evolved away from that now. And
Yeah, certainly the Grove would be unnecessary.
Yeah. And the thing is that it looks like from what I can get, I haven't been able to get my final answer from the guys at Intel, but I asked them what would happen if I used the non-calibrated on-chip termination for the memory. Would it work or not was the question. And the answer I get back is, don't do that. So they really won't admit that it doesn't work, but they really won't tell me that I have to do it either. They just recommend that I not use non-dynamic. But if I use the dynamic termination, I lose about 60 I/O pins out of the one bank. So now I got to go struggle to get the I/O pins other places. So if I could stop sharing this to see for right now, but so Tom, what I'm thinking of doing on the RF modules for this version, I'm thinking of deleting some of the I/O pins that we don't use and repurposing them to the other connectors because I'm going to be short pins now. So hopefully that's not going to, I mean, it won't break anything on the RF board because we don't use those pins.
Yeah.
But when we go do the next RF board, you're either going to have Mark II of the data engine with more IOs, or you're going to have to work around that limitation.
Yeah, well, you know, we've already up through about revision 20 on the ICD, so a couple more won't make any difference.
So what do you think about making, if I ended up making the two connectors not orthogonal, in other words, not the same pin out, would that be a heinous thing to do?
You mean, so the RF modules, the two modules would have to be pinned out differently?
Well, suppose that I took the extra pins off of RFM1, but left them on RFM0. So now the RFM0 and 1 are, our RF modules would work in either one, but extended RF modules might end up being able to be built that would only work in RFM0 and not 1. It's pretty ugly, I think.
Yeah, the description's vague enough, I don't understand.
Okay, well, there's 112 I/O pins on each connector, and we only use about 60 of them on the RF board, RF module, 60, 70 maybe. So I could take 35 pins off of RFM1 and 35 pins off of RFM0, and they would still be identical, but they just have fewer pins. Or if I only needed 35 pins, I could just take them off of RFM1 and leave them on RFM0, and then they become non-equal in terms of I/O.
Okay, well, if the RFMs are no connects to those pins, it probably doesn't make too much difference.
For this board, it doesn't. But for future boards, we wouldn't have the I/O pins, so.
Well, if future boards need them, then we have a problem. If they don't need them, we don't.
Right.
Well, you could build a new data engine.
And that's the idea, is a new data engine with a higher performance processor, because, you know, realistically, if you try to utilize all those pins, you're going to run out of logic elements probably before you utilize all the pins. So I'm just worried about something that's never going to happen.
Scotty, I'm not wanting to be contentious about this or anything at all. I'm just kind of inquiring. You're thinking. I know the FPGAs that you've wanted to use for these projects don't come with SerDes transceivers, but looking forward, if you were ever to discuss a different variant of the DE, wouldn't it make some sense to consider perhaps future FPGAs that do support SerDes transceivers and use these M.2 connectors kind of the way they were intended to be, or even your other connectors, and you're trying to move a lot of LVDS and a lot of data from the RF plugin into the data engine in parallel. It seems to me, as I understand it. Of course, I haven't really seen the architecture closely, but if you went to doing things in serial, which sure seems to be the trend, wouldn't that get you out of some of these quagmires, you know?
Yes, it would. And actually, there's Cyclone 5. When we go to the Mark II and use the Cyclone 5, there are versions that have transceivers that
Yeah.
we could use. So we could put those, and the connectors support that because the connectors are high enough speed. You could run the transceivers across that boundary, and you could use a GSD204 interface or some similar thing. But there's a big but, because most of those parts are much more expensive than the entry level. So I gotta restrain myself and say, look, this is the entry level, get it done, make it work. We'll go on to phase 2 later, like Bill does with me. He calls off the dogs by saying, well, we'll make that phase 2. So I don't make it overcomplicated for him because I want all these features, right? So I got to add all this stuff in.
Yeah.
So to avoid the creeping elegance problem, but you have a very good point, and that may be where phase 2 goes with, because GSD204 is much more performant.
Well, the trouble too is that especially having been bought by Intel, I get all the names mixed up.
Altera?
Altera, Altera doesn't seem to have a lot of interest at the low end for supporting SerDes. Whatever their strategy is with Intel doesn't seem to go that way. If you look at Lattice or even Microchip's, whatever the current incarnation of Actel is, so a lot of those things have a good bit more SerDes. They've invested in cheaper chips.
Microsemis, I think who you're referring to.
Microsemi. Yeah, I can't keep track. They change names too fast.
I know, it's hard to.
Microsemi is microchip.
Yeah, Microsemi is Microchip who bought Actel. Yeah,
right.
But for and I'm certainly not advocating anything about this at the moment. I'm just for future consideration. Does it make sense to keep an eye on what their strategic direction really is? If it's all for server, doing AI in huge server farms, it may not, one vendor may not really do the kind of things we want.
Well, I know one of the things that Nathaniel was wanting was 10 gig E. But as
Uh-huh.
soon as you do that, now you have a requirement to have lots more RF available because you've got this huge pipe now that you could fill.
Yeah. Well, there's a lot of these, even the SBCs are getting close to supporting 10G. A lot of them are doing 2.5, and which is, or at least they're, potentially doing 2.5. Certainly the NVIDIA ones, and some of the others. And you can go to things like graphics boards and stuff more easily because they're heavily invested in PCIe, whereas
Yes, that's kind of why I've been keeping my eye on, well, what we could do in the next generation, but not really getting too wrapped around the axle about it. Because
I'm not proposing that. Yeah, at all.
We got a lot to squeeze out of this before we go on to the next one.
Sure.
But so that's the kind of thing. Well, what's good? Should we have a 10 gig E interface? Should we have GSD204? Should we have bigger than 16 bits wide? Where should we go?
If you've got PCIe 2 and above SerDes, you've got you essentially, or at least the SerDes that supports that. It also supports USB 3.1, 10 gig ether. You can apportion it as you wish, but and it's easy to use it all up, and then you're out of lanes again. But still, it really it really runs you your transport from place to place, and some of your noise issues.
What's next? 40 gig E after 10 gig E?
Yeah, well, oh yeah, they've got it out there, but
typically 40 gig is 4 by 10 gig E implemented.
Is that how they do it?
Well, typically the 10 gig E is implemented with 4 transceivers, so you really only need 2.5 gig Well, you need more than that because you got overhead, but you don't need 10 gig transceivers to do it. But to do 40 gig, you're going to need like 12 gig transceivers, which they have, but
Yeah,
pricey.
typically 40 gig is implemented as a Q SFP plus. So it's essentially four SFP pluses in one cage.
So is
you
it
run-
4 fibers in one cable?
Yeah, no, it's four separate interfaces, or there's a multi-fiber interface. There's a couple of different ways you can break it out. But anyway,
So we'd have to put like 4 X2 interfaces on the board?
yeah, typically the way you run 40 gig E is it's 4 10 gig E's in parallel.
So physically 4 separate ones, okay.
Yeah, and you get a USFP plus card cage. Anyway, I've got to run. It's we're out of time here tonight.
Okay.
Yep. See you, Tom.
Bye-bye.
Good night, Tom.
Right.
Right.
Interesting points, though, Dave. I mean,
Yeah, I'm really thinking as much about the getting the data from the receiver to the FPGA or to anywhere you want it to go, not necessarily out. But yeah, you all those other things become options at that point, I guess.
and once you get to the FPGA, then you have the option of processing the data some way to reduce the bandwidth.
Yeah.
So,
the trouble is that these Altera that just doesn't, except when you climb way up the tree, doesn't seem to be producing much in this area.
The thing is interesting, though, is on the Xilinx side, the tree starts halfway up. So
yeah.
their low end stuff starts about the mid grade of Altera's. So I remember I went to a seminar on the X96 board. Is that the right board? Dave, you probably know about that one.
X96.
It's
yeah, that whole family. Yeah.
Yeah. They have an SoC module that Avnet produces that runs Linux and has an FPGA fabric side, but they put the second to smallest one on the board. And the board's like $200, but it's the second to smallest board, so it's pretty limited in what it'll do. And if you want to go to the larger parts, the price just goes up exponentially, and it just gets so expensive that you're spending $1,000 on just a chip.
Yeah. Well, I don't know how many what do you call it? How many gates or gate equivalents you need in the FPGA to do the things that are of interest here. I know you need, as you know, more is always nicer.
But I think that's part of the reason for putting a stake in the ground and building it. And saying, okay,
yeah, of course.
Then we're going to see where we run out, right?
Yeah. That's always the case with these things.
Yeah.
Scotty, I have a question for you. When you moved, were any of your old like SDRstick.com or your IQ2 in your office, or were they all offsite?
They're in the office, and we have on the list here is to put them up on a GitHub site somewhere so they'll be available to everyone. I just turned the machines off. I have the machines still, but I don't have a fixed IP address to serve them up anymore.
Okay.
And
I was just wondering because I did scrape SDRstick.com, at least the documents.
But the SVN is what you need, right?
Well, yeah, I did scrape through the SVN2 to get what software was there, just to make sure that if I knew that could, when it went off for a while and then it came back on, I said, well, I'm going to get a copy of all this stuff.
But yeah, that was supposed to happen before we moved, but there was a lot of things that were supposed to happen before we moved that ended up not happening because of the level of effort. So yeah, I do have the files. I need to get a.
We can make a GitHub for you.
Yeah. Okay. How about? Yeah, that's what we need. And just put those up there.
Yeah, I mean, just for documentation for people already own those parts.
Yeah. Well, I had a guy write me an email about the IQ2 a week ago, and I was busy with the move, and I didn't answer him. And he wrote me a hate mail this week saying how I was obviously not interested in selling any more radios and that I didn't respect customers and that blah, 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 blah. So I'm just going like, gee, end to a good week, you know?
Yes. Well, we got a question about somebody that's resurrecting their Aussie board, and they wondered drivers.
Oh, that's
That's a USB interface to the original Atlas.
yeah, and there was a set of drivers Bill had that
Oh yeah, George made a set of drivers, so that's not the problem. But you know, nobody asks you about those things for years, and then all of a sudden somebody asks you and says, "Well, how come you don't have that?"
Well, you know, we just went through moving our office, so we threw out just tons of paperwork from projects that were like 20 years old that we never heard from the people for 20 years. We're never going to build any more of these. We're never going to work on this. So what happens this week? A customer from about 2005 calls up and says he wants to make a mod to the board that we built for him. It's like you can guarantee as soon as you put that in the bin that customer is going to call you.
There's a Murphy's Law related to that. I know that there is.
You could probably build a better board cheaper with less effort today.
Well, it's a Cyclone 5 SoC, so it's pretty.
Okay.
It came out right when the Cyclone 5 was brand new.
Okay.
We could, and the thing is, he wanted us to build. He had a mini computer. Well, it was a PC, but he had a PC chassis from NI, National Instruments. He was paying $15,000 for it. And he put this alongside, and what he wanted from us was a analog data acquisition board to go with his NI board.
Oh.
And we talked him into moving the operating system onto the FPGA and building one board that has the whole thing and save him 15 grand, right? He didn't really want to do it, but then once we convinced him and we did it, he was really excited because it saved him a ton of money. And now this is the board he's coming back, and he wants us to make some hardware changes to.
Ouch.
And like Shirley and I are going like, now what was the ADC rate again? We don't even remember. I don't even remember what ADC part we used. So it's going to be bad.
Well, I have back when Anna was trying to build something with a Cyclone 5 SoC.
Oh, the socket.
I bought that.
Yeah.
I bought that board, and I never got into it because I just got confused every time I started working with it. And I think Anna didn't get it very far, got quite a bit further, but finally gave up because of frustration.
Well, we have a radio working on that platform.
Well, I have a board.
You have an AD1 and an HF2, right?
No, I mean, this is the one that we were fooling with. It's not part of your set.
It has the
HFC
connector.
I have an HF1, an HF2, and a TX2 of your boards, and the A9 board from Altera. But then I had another one, the SoC one.
At the socket
that
board.
was an Altera development board.
Right, from Jurassic, right?
Right.
It was the 300
and I have that.
Jurassic. Right,
Yeah.
and that has an HSMC connector on it.
Yeah.
And we built an AD1 adapter that converts HSMC to MSC.
And I have the adapter.
So then your HF1s and HF2s will plug on that adapter, and we actually have firmware to make that. I could probably get you a copy of the SD card if you want it. It would just come up and run. You wouldn't have to really do anything. But if you want
that
to make
I would like.
But if you want to make any mods, then good luck, because I don't. Charlie built all that, and I don't even.
Right.
That's so far back in memory. I don't know if I could dig it out or not, but I could get you an SD card.
If you could send me an image or something that I could put on an SD card.
Well, we'll probably just borrow one from Charlie and copy it, and then that'll be
okay.
Because we haven't worked on it in like 5 years.
Yeah.
It's
I have all these parts sitting around that I'm not using. So.
Well, HF1s came out in 2013.
13.
I can't believe it's been that many years. That's like 7 years ago.
Yeah.
Where does the time go?
Well, I remember you convincing me to buy a penny and it was a penny and not a penny, an Atlas board, an Aussie. No, it wasn't even Aussie. It was Janus.
Ozzy and Jan were the first two that we made.
You had just bought a SDR 1000.
Right.
And you wanted to use it, and you were convincing me at Dayton to get involved in this.
Oh no, so it's my fault then. Oh no.
Well, I'm still here.
And that was
So,
2008, right, or something?
probably 7.
7.
I went to a talk, the Tapper talk, and Lyle was still talking.
Yeah, that was 2008, I think. Because it was Flex, Gerald was talking in 06,
Yes.
I think.
Okay.
That's what got me fired up. Was Eric Ellison and
Yes.
Gerald. Those two guys got me fired up about ham radio again.
Yep.
Because it was just kind of dragging on, and then they start talking about SDRs and computers and look, you can get better performance out of this SDR 1000 for less money, and then it got
Like,
exciting.
how many HTs can you buy?
That's right.
That's what it is for a lot of people.
We won't discuss how many HTs I have. It's a disease.
Now it's become how many Raspberry Pis can you buy?
That's right.
Somebody is doing a survey every time there's a convention or group.
Yeah, that's me.
Well, I would say, hold up a hand. You're doing that?
That's
Yeah, that's
Scotty.
right. Did you have 20, 30, 40, 50?
The last record was 25. And I told him you have to subtract ones that are still in the box. They have to be out on the desk or in equipment or powered up somewhere. And he still had his hand up at 25.
Wow.
I'd like to see his house. He's probably not married. Because his house probably
Here,
looks
on a completely different subject, I took a picture off my back porch last week. Let me show. Host disabled person. Can somebody let me share my screen? Let me show you this picture I took last week. Who's got the ability to? I think that probably Nathaniel. I think he.
Well, I have host, but I'm not.
Yeah, maybe you'll have to do it,
What
Dave.
can I do?
I don't see.
Host can do it too. Should be able to.
Because I click under more and I can't. I can put in.
Oh, I can see. Just a minute. Let's see if I can get rid of this.
I just had to do that last night. I can't remember how.
Isn't he on the phone, so he can't do video?
No,
I'm using the phone only for audio. I've still got video on the screen on the computer. My computer sound interface card quit working. I got to reboot and see if it's the software trash.
So, Bill, I just made you a co-host.
There you go.
Okay.
Okay, here. Let me see. Screen.
Oh, you know what? Oh, never mind. I'm not sharing anymore.
Be that way.
Wow, that's off your back porch?
Yeah, I just took
Neil
my camera and
Wise?
I just took a 2-second time exposure.
That's the comet.
Right.
Yeah, that's comet. It was. I mean, it's not in the sky, and here you can see where a plane came through the through the picture, and then there's a few more. But trying to get better. Now then later, I played with the focus a little bit more, but the sky was. This is a couple of days later. The sky was a little bit cloudy and stuff, so you can see it in there, and that the stars are a little bit better focus. This is just with a 35 millimeter lens at f1.8 and 2-second time exposure. I think ISO 2000.
Wow,
that sounds
pretty good.
Right.
My brother over in Atlanta has been doing this with he takes his telescope cameras and he can put 35 millimeter lenses on them and just using them off the, I think it, I don't understand it all, but he lives in the middle of downtown, or well, in Decatur. He lives right in the middle of downtown Atlanta, essentially near Emory. And but he's been getting pictures like not quite as pretty as this though.
I like this one because the colors in it.
Yeah, that's nice.
And the sky was completely dark, but if you take a 2-second time exposure, the minute amount of light that's still coming over the horizon and air glow and whatnot gives you this color. So the sky, to the naked eye, the sky looked completely dark. Then I took the photo and got this.
That's pretty good.
So anyway,
I got photo bombed a couple frames by the space station.
Oh.
There was one night the space station flew right past it.
Oh, so you've got a picture with the space station going through?
Yes.
Like a streak? It appears
Yes,
as a streak?
a short streak, because I was probably running, something around 2 second at, I think I was f4 2 seconds, 6400 ISO, 70 millimeter lens.
Yeah. Well, I've seen a pearl chain of the SpaceX internet satellites come by one after another, and that would drive an astronomer crazy, I would think. But
those are horrible. Somebody's going to have to design a vacuum cleaner satellite to go up and pick those up.
Yeah.
I can't believe he's taking liberties to put those up there.
He's not the only one though.
Yeah,
he's the only one putting thousands up, and it's like, I can't believe there's no international entity that you have to check that out with. But how are we going to shoot anything else up there with those flying around?
It's like mosquitoes.
Didn't the guy from AMSAT say that when you launch a satellite in the U.S., you have to make arrangements for its removal when its lifetime's over? Did I hear them talking about that?
You do.
Well,
you do.
That's true about CubeSats. But
oh, okay.
I don't know. If he puts them up himself, I don't know what.
But there's another constellation, I think, that's getting ready to go up. That's Indian. There may be more than one, but an Indian-based one that they were worried quite a bit about.
At least 2 companies are working on it, maybe 3. But they do have these satellites, these SpaceX satellites. They're able to maneuver, and so they have a certain amount of fuel, and they're going to push them up into higher orbits. So they think they might not be as obnoxious, but I don't know.
And then they eventually fail and don't come down. The higher the orbit, the longer they'll be up.
Yeah.
Yeah. All right, anybody. I'm falling asleep
well, I'm going to turn off the audio recording. So 73.
All right. 73. Take care. We'll talk to you again soon.
Yep.
73. Have a good night.
Good night. So Dan, you're still muted. Go ahead, Dave.
I'm trying to see. You still have. Let's see if. Oh no, that didn't do it. We still have the recording.
Oh, it's still going?
Yeah, I can't figure out. You see that little cloud with the dot? Oh, here it is. Stop.